Okay, it says for the following exercise, consider this function f of x equals 7x to the 1/3. Find f prime of x. So to find f prime of x, we're going to use the limit definition, the limit as h goes to 0 of f of x plus h. So we're going to take the function and put in x plus h. That's to the 1/3. Minus, we're going to put in x, so 7x to the 1/3 all over h. Now, in looking at this to see what we could do with this, we are going to use a substitution that might not be something you thought of doing, but see if you can follow it as we do the substitution. Our issue is we have these things to the 1/3 power, which is like a cube root, and using the conjugate isn't going to get rid of the root because it's a cube root. So what we're going to do is this. We're going to define a substitution. We are going to let this piece be a and this piece be b, and I'm going to use one of the properties of limits, which says when you have a constant, I have a 7 in both pieces. I can factor that out, and in fact I can bring it out in front of the limit using the limit properties. So I am going to bring the 7 out in front, and then I'm going to have the limit. And before I put that in, let me write out the substitution I'm going to use so you can kind of see how it's going to work. So we are going to have a be x plus h to the 1/3, and we're going to have b be x to the 1/3. So I would have the limit here, and I'm actually not going to have h by the time I'm done, so I'm not going to put what the limit's approaching yet. I've got to change that to my new variables, which I will do in a minute. So I'm going to replace the x plus h to the 1/3 with a, and then minus, and we factored out the 7, so I have x to the 1/3, and that's b over, okay, then we have h in the denominator. So I need to do something with my substitutions here to solve for h. So in this first one, I'm going to cube both sides and have a cubed equal x plus h. So solving that for h is going to equal a cubed minus x. I can replace h with a cubed minus x, but I don't want x. I want to try and get this in terms of a and b. So I'm also going to take the b function and cube both sides, and that tells me that x is b to the 3rd, so I'm going to put this b to the 3rd in right here. So the h I'm going to use is going to be a cubed minus b cubed. Okay, so that's the denominator, a cubed minus b cubed. Now, in looking at this, then we need to figure out what the limit would be when h goes to 0. And if h goes to 0, if I put 0 right here, that means a cubed minus b cubed equals 0. So if I want this to go to 0, I'm going to let a cubed approach b cubed. So a cubed approaching b cubed. Because I can't, if I let a cubed approach b cubed, I'd be dividing by 0 here. So what I want to do is see if I can algebraically manipulate it. Now I've done the substitution, and I can because the denominator is the difference of cubes. So I'm going to factor this. So I'll have 7 times the limit as a cubed approaches b cubed of a minus b over, factor the difference of cubes, that's what got cubed and what got cubed, and then the first one squared, and then multiply the two together but change the sign, and then the last one squared. So this will now factor into that which has a common factor in the numerator and the denominator, so I can reduce that, and then that's going to leave me a 1. Okay, so we've done some algebraic manipulation. Let's take this and I'm going to rewrite what we have down here below. So that is going to equal 7 times the limit as a cubed approaches b cubed of 1 over a squared plus ab plus b squared. Now, I am actually going to get it back in terms of x and h now, and then I'm going to evaluate the limit. So we're going to make our change of variables, get it back in terms of x and h. So to do that, we've got 7, and then the limit as h goes to 0, 1 over a squared. Okay, what was a? A was right here, x plus h to the 1/3, and I need a squared, so it's going to be x plus h to the 2/3 because I'm squaring it. It was 1/3. And then next I have ab, so I'm going to do plus. A was x plus h to the 1/3, and b was right here. B was x to the 1/3, and then I've got plus b squared. I'm going to write it down below because I'm out of room, but b was x to the 1/3, so b squared is x to the 2/3. Okay, now I'm going to go ahead and let h go to 0 because I don't have anything undefined. This is going to be 0, this h is going to be 0, and then I've done the limit. So let's write down what we've got, and I'm going to put it up here where it has the a. What do I have left? I have 7 on the top, and on the bottom I have an x to the 2/3 and an x to the 1/3 times x to the 1/3, which is x to the 2/3, plus another x to the 2/3. So I have 3x to the 2/3, and that is what the derivative equals. So that one was a tricky one. That's why I've made an example to help you with that. Now let's see if we can answer the other parts. So part B says evaluate the limit as x approaches 0 of f prime of x. If the limit is infinite, enter either infinity or negative infinity, otherwise it does not exist. Okay, so let's see what we've got. We've got the limit as x approaches 0 of, I'm going to write the 7/3 out in front because that's the constants, and then this is times 1 over x to the 2/3. If we're wondering what happens when the denominator approaches 0, it's undefined at 0, and so we know that's a vertical asymptote. This number is 7/3, that's positive. This number, because we are squaring it, is going to be positive. And so if we approach from either side, it would be going towards positive infinity, so this limit is infinity. What does the answer to part B say about the tangent line to the curve at the point 0, 0? Now if we look back at the function, you can go ahead and put 0 in the function and you would get 0. So the point 0, 0 is on the function, but we were trying to find the tangent to the curve, and we found this formula for the derivative, but as we tried to approach 0 to see what the tangent line is doing, we saw that was an asymptote for the derivatives, and therefore it was going to infinity. So that's the choice we need to pick, is the graph, it's right here, has a vertical tangent at the point 0, 0.